and welcome to our Tech Masterclass session on autoscaling Kubernetes clusters. I am Horacio González, and I work at Developer Relations at OVH Cloud. And in this presentation, I have with me Kevin George, Engineering Manager of the OVH Cloud Managed Kubernetes, and Maxime Urtrel, Product Manager of the Managed Kubernetes. So, what are we talking about? Well, in Kubernetes, there is no native way to autoscale a cluster. That means that if you try to deploy your pods and your cluster is full, the deployments are going to fail. We have recently released a new feature in our Managed Kubernetes. This feature, Node Pools, allows to manage the creation and the deletion of nodes directly from the Kubernetes API. So in this masterclass, we are going to see how we can use this new feature in order to create an autoscaler for your OVH Managed Kubernetes clusters. The idea is at the end of the presentation, you will be able to do it by yourself. Of course, all the code and all the instructions in order to replicate what we are doing here are on GitHub in my GitHub repository, github.com, Lost in Brittany, perdu en Bretagne, pour le français, /OVH Cloud kite is autoscaling demo. You have seen the URL. And what are we going to see? Well, you are going to code your custom autoscaler. You are going to choose how do you want to autoscale and what parameters you take into account. You are going to use two small pods, two small deployments. One that deploys a prime numbers image. So that image is only a very nice prime number calculator that consumes lots and lots of CPU. And memory grabber is another similar one, also very nice, but this one it uses lots and lots of memory. Why? Because we are going to spawn these two pods, lots of replicas of each one, in order to add a lot to our cluster and see that our autoscaler works. And of course, we are going to need UI, so we are going to use a Kubernetes dashboard, but not a normal one. We are keeping it in the theme, and we are using a Kubernetes Invaders and a Space Invaders theme dashboard. We can begin, but before beginning, Kevin, please can you explain us how the horizontal pod scaling works in Kubernetes?
Yes, sure. So today we are talking about autoscaling. In fact, we already have autoscaling in Kubernetes. It's working on deployments. The main goal of autoscaling is to ensure that our applications only run with the right amount of resources, which ensure cost efficiency. And so Kubernetes already have autoscaling available. It's based on deployments, as I say. So it will add new pods as the load grows, and it will remove pods if the load decreases. But what happens if perhaps is a great success? So we have many requests on it. The autoscaler will add new pods, but when we reach the capacity of the clusters, it will fail to start new pods. So let's see in applications how this works. So let's deploy a simple deployment. So it's an app. So we will do kubectl apply deployments. So you would create deployments with a PHP app. We do prime number computation, so it's CPU intensive, and a service for accessing it. On another container, we will run a load test, which AB, which is the benchmarking tool for Apache, and we will launch a request to the EcoX app, which is the app that we just launched. So let's go. Now, if we do kubectl up for pod, we will see the amount of CPU consumed will increase. Should happen. And what we have set up for deployments, describe deployments, we have containers and we have limits, which is on CPU and also request. Scheduling of pod is done on request, but limit is a limit which protects our infrastructure. So now the load should increase, and we'll see that your applications, it's at max speed. And so we are losing request because we can't handle the load. It's limited by Kubernetes by itself. So what we can do, we can start an autoscaler on the deployments. So we do kubectl autoscale deployments on our app, which is ecoexp. And we will set CPU percent, which will be the trigger for the load of the CPU. Let's set it at half. And we will set a min number of pods, 1, for example, and a max number, let's 25. So we just started the autoscaler. We can get it as any Kubernetes resource. So right now it's up now because we just started, but soon we will see the load. We will also see number of pods being increased. So that's it. This scheduler taking account horizontal pod autoscaler, and we see that we are running way above our limit, which is 50%. And so we will see new pod being scheduled. So they're running. The number of pod just start to handle the load. But if we take the HPA, we are still over capacity. So it will continue to launch new deployments. And if we get pod, we'll see that now we have many pods because we try to handle the load, but most of them stay in pending state because all the nodes are full now. This is the top node. And okay, and if we describe your node, get node. Sorry, please describe. We'll see that all your nodes are full in terms of CPU, but we still can handle the load. That's why we need cluster autoscaling in order to add new nodes, new clusters, to follow the increase of the load.
Fais une petite pause à couper ici. Tu peux faire un describe de un qui c'est pending pour montrer le type de message qu'il y a?
Ouais, si tu veux.
Ok, pardon, je mettais à nouveau.
Non, mais c'était la fin de toute façon. And so let's see one of the pod which is not scheduled and see why it's not scheduled. The first one, for example. And so we see that it's fail scheduling because we are run out of CPU. That's why we need to add more nodes dynamically to our clusters, thanks to the cluster autoscaler.
So, Kevin, you have just shown us how the horizontal scaling works, but what we would like is to have the same things at the cluster level. How could we do that?
We can do that with the node pool features, which is a feature that we had recently on the offer, which offer a way to manipulate through nodes and the number of nodes on our clusters, thanks to the Kubernetes API. And so we'll let Maxime explain you in details what is node pools and how it works.
Yes, indeed, Kevin. As we launched the product a bit more than a year ago now, we see more and more customers that regularly have to scale up their cluster, sometimes to scale down and multiply the number of clusters they have. From the beginning of the offering, like any OVH Cloud product, we offered the possibility to manage that through HTTP API. But as you just explained, we see a lot more value in allowing to manage that directly through a Kubernetes resource. That's why we offered the node pool feature. Just before showing how to manipulate it through Kubernetes, and we will use that in the autoscaling feature, let's see what it looks like in the customer panel, in the web interface. Let's have a look at the Manage Kubernetes section within the public cloud section of the customer panel. You will see at the top a new tab called Node Pools, and this is where you will manage your node within your node pools. We can see here that we already have one node pool. Let's see what it looks like. It is composed of 3 different nodes. All the nodes have the same flavor. This is a basic concept of the node pool. And we can easily either destroy a given node or directly add new nodes or delete multiple nodes at the same time using this action toolbar. As I just explained before, you can also manage node pools through the OVH Cloud API, but more interestingly, you will have a new custom resource definition deployed within your Kubernetes cluster that you can directly manipulate through standard tools such as kubectl, for example. So if we open a standard kubectl with no plugin required, we can list the different node pools within our Kubernetes cluster. We see that we have a single node pool with 3 B27, and we can ask more details about this node pool. It's interesting to know that we just released the possibility to create new node pools with monthly billing. We also now manage affinity, or more exactly anti-affinity, the capability to have a node pool spread across multiple bare metal servers. And finally, that's what interests us in the demo. We can scale the number of nodes within a node pool as we would do in a standard deployment of pods, for example, with the scale command. Here we're going to scale this node pool from 3 to 5 different machines. Do that in a single call, and if we look again at this node pool, we will see that the desired number of nodes within the node pool is 5. We currently have 4 nodes. 3 of them are ready. 4 are available, sorry. And a 5th one will be spawned within a few minutes. So we now know how to scale quickly a node pool. I think it's interesting for you to know that we will offer autoscaling directly in the offering at the end of the year. However, we will do a one-size-fits-all, basically, autoscaler. This means that we will do some choices for you in terms of what criteria the autoscaling is based on. And though you will be able to a little bit trick the autoscaler, it's always interesting to know how it works so that you can do a more specific one for your specific use case. For example, if you've got stateful workloads, you will have to manage how the persistent volumes are attached, etc. So let's move back with Horacio and see how to leverage the node pools within a specific autoscaler.
So, as Maxime said, we are going to implement our own autoscaler. We are going to implement an autoscaler that it's going to be able to add or remove nodes as we need. My criteria need to be simple, something easy to observe, easy to get using the Kubernetes API. For me, I need to get the global request in every node, and I need to get the global request in the cluster for CPU and memory, and the global capacity of every node and the global capacity of the cluster, and then doing some kind of rule. Let's see how it works. So here you have the Kubernetes Embedder's dashboard. It's a very simple dashboard that using the Kubernetes API get all the information necessary to understand how the autoscaling works. So we are going to get all the node pools in our cluster. For each node pool, it is going to show us how many nodes there are currently. They are going to give us the global load of the cluster in CPU and memory, and it is going to show us the different pods that are in our cluster. I have put in orange the system pods like metrics or canal, wormhole, or other pods not for this demo, like the Velero pod that is going to do the backup of the cluster. Are in green, you have the prime numbers pod, one of the pods that it's going to need lots and lots of CPU, and then the memory grabber pods. They take a bit less CPU, but a lot more memory. So we have 6 memory grabber, 4 and 2, and 4. And we see that our cluster is mostly well loaded. So if I go to the Autoscaler console, I see that 71% CPUs, 62% memory, and for the individual nodes. So what happens if we add some new instance? For example, we are going to add a prime number pod. It's going to be scheduled, yeah, and then it's going to get ready. So we have 3 and 2 now, and our load in CPU has increased. We add another one. Yeah, we have 6 scheduled. 1, 2, 3, 4. And our load is almost 80%. And for this demo, I have put the limit at 80%. So if I add a new one, we are going to cross that limit. And then what happens? Well, here you see we have crossed the limit, so we launch an auto-scaling. The autoscaler detects that we aren't in a safe situation and it creates a new node. Why have I choose 80%? Because there are several strategies you can choose when you do an autoscaler. The first one is really simple. If you try to deploy a pod and you cannot because you have no place, so you have an error by deploying a pod, then you are going to add a new node. But it is a bad situation because you will get a delay. As you can see in the demo, adding a node isn't instantaneous. You need to wait 2-3 minutes. So your deployment will be blocked for 2-3 minutes. Another strategy is to try to be proactive. So if you see that you are reaching the capacity limit, you can deploy a new node in advance to be sure that when you try to deploy your pods, you will always have enough CPU and memory in order to deploy. Then, as you can see here, we have a third node that has appeared in the UI. It isn't completely ready, so you still get the node creation message here, but you already have the node and the global load has been reduced. So now we can add new pods, for example, a memory grabber and a prime number. The node is now stable and we are slowly increasing the load. And if we go back, yeah, we see that the global values are under control. But a nice autoscaler that this one has another problem. Sometimes the global load is small, but the nodes are globally under pressure. Here, for example, the first CPU, the first node has a global CPU and memory rather loaded. the second one only the CPU, and the third one is almost empty. But if all three have one parameter high, you could have problems. You could find a deadlock situation when the scheduler cannot place a pod in one node because of CPU and in another one because of memory, even if the global load isn't so high. That's why I am adding a third criteria to my autoscaler. So enough told about my autoscaler. Let me show you it. Well, the autoscaler, it's a sample Node.js container. It's a Node.js program running on a container put on Docker Hub and deployed as a normal pod in our cluster. I am not going to detail all the code here. You have it in GitHub. But as you can see, I mostly do lots of calls to the Kubernetes API to get all the information about my cluster. Here, for example, I am calling the nodes API in order to get all my nodes. And with that information, I am later calling the Kubernetes metrics API in order to get the real load of all these nodes. That's like if I did a kubectl top. I am also aggregating all the results because the idea is at the end, I want to have that, the global load by node and the global load for the cluster. And I think the most interesting part here is the autoscaling. Here is it. So once I have the global load, I can begin to calculate where I am for the different limits. I begin calculating the global load as a percentage, and as Kevin explained it before, we are using the requests. Requests are one of the two types of resources that you declare in your Kubernetes manifest. Let's see my prime numbers. In my prime numbers manifest, I am declaring that my pods are going to consume at least 150 milli CPU, and in memory they are going to consume 15 megabytes. And I am going to give also hard limits. Hard limits, that mean that my CPU consumption can go up, my memory consumption can go up, but I don't foresee them to be higher than 300 milli CPU or 30 megabyte. And if it is higher, I am authorizing Kubernetes to simply kill my pod. How the Kubernetes scheduler deployed pods? It uses the requests. So if you have two global CPU in one node and you are using 1.9, I won't be able to deploy this pod because it needs 150 milli CPU. I only have 100. So when you have problems deploying pods, when the scheduler is unable to deploy one pod, it is because the request you have declared. So in my autoscaler, I am using the global request in order to calculate the percentage of load in CPU and memory. And I am also adding the other parameter. I am looking for every node, and if all the nodes are loaded either in CPU or in memory, I think it is a bad behavior because I could have a deadlock when trying to deploy. And then, once I have these parameters, okay, if the memory is over 80% or the CPU is over 80% or all the nodes are under pressure, then I increase my node pool. And if all the nodes are under 50% of memory and CPU, and if I have at least 4 nodes, I am going to reduce. Why this last part? Because we don't recommend to have node pools under 3 nodes. Why? Because in the normal Kubernetes behavior, the scheduler works better if there are several nodes to schedule pods. And if one node has a problem, the scheduler will be able to basculate all the load to other nodes. If we are doing a version upgrade of your Kubernetes nodes, it is nice to have other nodes able to support the load. So in my example, I am limiting the size of my node pools at a minimum of 3. And then, how are the increase or decrease done? Hey, like we have seen before, only using the Kubernetes API. So we are doing a patch in the node pool, and we are changing the desired nodes. We are getting the present value and adding 1. And to decrease, same thing, we do a patch in the node pool, in the chosen node pool, with desired nodes, the present value -1. So that is how the auto-scaling is done. You could have a lot of complicated business logic in the auto-scaling method. For example, if you are doing many stateful deployments, you should also want to control the persistent volumes and other things like that. Or if you are deploying a kind of periodical pods that are scheduled every 30 minutes, you can have different strategies, but at the heart, they are rather similar. You see if you need to increase and you call the API, if you need to decrease and you call the API. So, as you have seen, all the code for this demo is done in JavaScript. It is in the GitHub repository. You will find the Autoscaler. You will find the 2 kind of pods and the deployment for them, and you will find the UI that it's also done in JavaScript using web components. So you will be able to integrate and modify it and integrate it in any JavaScript framework. So in this masterclass, we have shown how you can create an autoscaler for your OVH Cloud managed Kubernetes clusters using the node pool. Using the information in the masterclass and the code and instructions in the GitHub repository, we hope you will be able to create a custom autoscaler adapted to your needs, or using a sample one like the one we have shown in the demo. You can also add lots of other options, like, for example, setting mean and max number of nodes in your node pool in order to avoid the autoscaling increasing to 100 nodes, for example. So you can fine-tune also these parameters. And using this strategy, your OVH Kubernetes cluster is more flexible, more useful. We are preparing an official autoscaler that will be available in our OVH Managed Kubernetes service. For more normal needs, it will be enough because you will be able to choose the right parameters, but there will always be a lot of use cases in which having a custom autoscaling is interesting. So you can always use the strategy we have seen in this masterclass for this kind of use cases. And as usual, we have done this node pool feature based on feedback of our customers. As we like to say, we are change makers, and we take all the feedback and all the suggestions of our customers and try to use them to improve our products, improve the usefulness and the easiness to use of all our services. Now, if you have any questions, suggestions, feedback, there is a good moment because we have a live chat. So please come and speak with us. Thank you very much.